Afternoon. Big Bear Engineering is here to present County Road 38 corridor improvements. I am Michael Prescott, the project manager and structural engineer for this project. Zack is our transportation engineer. Richie Young is our geotechnical engineer. Holly Taylor is our water resource engineer, and Ryan Manderfield is our environmental engineer. So Big Bear Engineering promises a sleuth of engineers to make a quality, safe, and innovative design. That is our vision statement. To give you an overview of the project, the transportation project consists of County Road 38 and State Route 15 intersection design and the County Road 38 corridor. This is in Goshen, Indiana, to keep you all in mind, with pedestrian accessibility. For geotechnical, we're doing the location, soil analysis, and visitor center design. Structural is doing a 50,000 square foot visitor center. Hydrology is doing a watershed delineation along with stormwater management. Environmental is doing water treatment plant along with visitor center wastewater. Again, to give you a brief idea, Goshen, Indiana is down over here, whereas to give you an idea, that's closer to South Bend, Elkhart. The star is the location right at where we are doing. And I will pass it off to Zach for our transportation.
Thanks, Mike. So the transportation project scope, as Mike said, included the County Road 38 and State Route 15 intersection improvements, which is shown here. That is the current layout of that intersection. And then the corridor design and connection that's going to be between County Road 21 and State Route 15 along the County Road 38 corridor. And then finally, there's going to be pedestrian accessibility through the use of 5-foot sidewalks and a 10-foot multi-use path along the northern portion of that corridor. So a little bit on the background on why we kind of had to do this project. So we're looking at a 20-year design life for the intersection and the corridor. The actual intersection corridor had safety concerns. This is basically because of the poor LOS, which is level of service. It's basically the grade on the intersection as how well it is performing. The VC ratio is volume to capacity, so what the intersection can hold versus what it's actually receiving. And then the overall delay, so how long you're sitting at a light at the intersection itself. The road itself, it's old, it has potholes, poor road conditions. You know, it's Indiana, it's in the north, that's what we get. There was a high volume of trucks, about 8 to 10% of trucks on that corridor, so that also had to be taken into consideration. And then there was currently a lack of sidewalks and any sort of pedestrian accessibility. So there's a lot of industrial portions just east of this intersection, so we had to look at kind of getting pedestrians from a northwestern suburb kind of towards those industrial locations. And then also we were looking at improving the actual intersection itself just for the visitor center that's going to be placed at the southwest quadrant of the intersection. So I looked at a few impacts when actually determining my alternatives for the intersection and the corridor design. So for my analytical impacts, those would include things along the lines of safety, the level of service, the volume to capacity ratio, and the actual overall footprint of the intersection. And then for economic and financial impacts, I looked at things like local jobs, the serviceability, pedestrian accessibility, right-of-way acquisition, and your total estimated cost. And finally, for social and cultural impacts, we looked at the environmental impacts of it, the actual traffic. So how is the traffic going to be affected through the project? Light pollution, because we are going to be adding a lot of lights towards this intersection that's currently not very well signalized. Noise, and then finally we wanted a very aesthetically pleasing intersection and corridor, because right now it's pretty run down as it is older. So here's our typical cross sections for the corridor itself. West of the Elkhart River, you're looking at a 2-lane configuration at 12 feet lanes, 10-foot paved shoulder, and then 3-to-1 typical ditch line. And then just east of the Elkhart River, we actually transition into a 3-lane configuration, 12-foot lanes staying the same, and a 12-foot bidirectional turning lane in the middle. And then on the edges, we're going to have curb and gutter to maintain our hydrology aspect of that. For the pavement design, which was actually done by our geotechnical engineer, we had a 1.5-inch surface course, 3 inches of HMA intermediate, and 7 inches of base course, and that is going to be followed by some stone and some geotextile layers. Going into the intersection design, as you can see there at the southwest is the visitor center location for our visitor center. The multi-use path is on the northern portion there, that is 10 feet wide, and then sidewalks are going to run throughout the intersection and just west of the intersection just along Martin Manor Drive, which is a right-in, right-out access for the visitor center. The main access for the visitor center is going to be just south on State Route 15 down here, and that is going to be an all-access access for the visitor center. The visitor center, we did choose a 3-lane configuration on all approaches, so some of them we did have to add lanes, so it's going to have a left turn lane, a through lane, and a right turn lane for the intersection itself. The County Road 38 center line is going to remain roughly unchanged from the current center line, and the State Route 15 center line is offset at the intersection just due to the geometry that the roadways come into it. So for the actual plan view of the County Road 38 corridor, we're starting at County Road 21. It is Indiana, so there is not much horizontal geometry to this roadway for a few hundred feet until you get towards the river portion. As you can see there's the northwestern suburbs, and that is where we will start our multi-use path. And then that's also where we transition from that 2-lane configuration to that 3-lane configuration. And then finally going in, this is how the 3 lanes will kind of connect pretty seamlessly into the actual intersection portion and the auxiliary lanes that are going to be required for that intersection itself. Up here we do have a property relocation. Based on the geometry of the intersection and the corridor, we really couldn't kind of shift it how we wanted to. It's kind of a catch-22. So that is just currently a garage, so we will be relocating that garage to somewhere else on the property. Finally, we're going to end it just west of the railroad tracks, right before kind of the industrial part of Goshen. That's kind of where our limits end, and we are going to make it so the multi-use path and the roadway itself can be kind of extended in the future towards that industrial park. And then finally, I do have a detour route for the roadway itself, because we are going to be closing down County Road 38 just because of the volume of traffic and how difficult the project and the intersection is going to be. So the actual detour is going to still maintain residential and the orchard access, but then we are going to detour people up County Road 21, across County Road 119, and then down State Route 15. State Route 15 is always going to have 1 lane open at all times. Finally, talking about money, we have the construction cost. I'm looking right around $2 million, and this obviously does not include any sort of subgrade improvements because that is covered under our geotechnicals cost estimates. And the property relocation is also included in this cost. And with that, I'll pass it off to our geotechnical engineer for his portion of this.
Hello, thank you, Zach. I'm Richie Young, the geotechnical engineer on this project. To begin with, I was tasked with determining the appropriate locations for borings where we needed to understand the soil properties of the site. Because of that, from County Road 21 to about Violet Road, it was mainly consisted of silty, sandy clay, which is just not a very great soil to work with. Past that point, past the Elkhart River, it transitions to about silty sand. So then moving on, for the visitor center, we decided to propose 3 locations, and our structural engineer approved the final design. Location 2 was quickly rejected just because of its placement near the floodplain, while locations 1 and location 3 appear to be optimal locations just due to location 1 being right by the river. It would seem like a very scenic place, and location 3 being away from the river but in a very urban area. So our economics and our just impacts in general, I'm mainly focused on just the aesthetics and the cost of designing the foundation that would be needed. It must be noted that location 3 was moved over to here. This is due to the structural engineer deciding that the acquisition of location 3 would just be too expensive. So this is the final design that we came up with that new location in mind. We were designing 3 different shallow foundations. This is just an example of what the shallow foundation would look like with a 16-inch pedestal. And then moving on to the cost. By my calculations, it cost approximately $360,000. And then I would like to transition to our structural engineer, Michael.
Thank you, Richie. Project scope called for a 50,000 square foot visitor center along with adequate parking. It must be aesthetically pleasing and unique as many visitor centers in the area. Multi-use building must benefit the community, and it must be maintained and enhanced for years to come. Design completion date is 2019. So going over the locations I was kind of thinking about for this project, Location 1 and 2 were mainly closer to the river, whereas they were in the floodplain, and that would require lots and lots of permits, and I didn't feel like it was necessary. It's going to be a cost hassle. So location 3 was the perfect location for the visitor center. It was much more in the city limits and right by the intersection which we are designing, so we felt like that was a necessary location for the visitor center. So here's kind of the overview of what the visitor center will look like near the intersection. As you can see, the green here is the green space we are replenishing. Per requirements, we need 20,000 green space, or 20,000 square foot of green space required to be replaced, and we added 30,000 square foot of green space. The main entrance is off of State Route 15 that runs along here, whereas our proposed secondary entrance is along Martin Manor Drive, whereas we have a right in, right out off of the County Road 38, which we are designing. Here's kind of the 3D rendering of the visitor center, whereas on the second floor we have an overlook on both the north and south side. No, the Big Bear Engineering logo is not included on the roof. The first and second floor, this is kind of the layout of the visitor center. Obviously this will be more designed by the architect, but the first floor is for tourism and city and county officials. Same as the second floor, we have a lot more offices for more city and county officials, whereas a large conference room for more large events. Parking lot design, we have 185 spaces for the parking lot, 170 was required. 7 handicap spaces for the ADA requirement with 1 van accessibility spot. Like I said, we're replenishing 30,000 square foot of space along with the main entrance on State Route 15 with the secondary entrance being on Martin Manor Drive. For social and economic benefits, like I said, it must enhance the community, it must be aesthetically pleasing, pleasant views with the overlook we have involved, and educational impacts, great for schools and stuff to come to the visitor center to learn about the community. Economic impacts, increased jobs, tourism, local economy, costs. The cost breakdown, unfortunately, we are acquiring 4 properties, and that's due to the parking lot size. And that was estimated to be about $591,000, whereas steel cost breakdown, these are just some of the lists of the members I've used. I didn't really want to go too in-depth into technical details, but we have about $815,000 of just steel costs. And the overall cost breakdown, this includes the property and the steel cost to be about $14.6 million. I will hand it off to Holly for hydrology.
So for the hydrology scope, we had to reduce the runoff of all of the water, increase the infiltration, and reduce pollutants. And so on the west side of the river, as you can see down here, there will be vegetative soils. It will help infiltrate the water, reduce the runoff speed. It is cost effective. It will have 3-to-1 side slopes with a base of 3 to 9 feet. So over here, these would be the side slopes, and 3 to 9 feet here. The base depends on the right-of-way that we have, because we really didn't want to acquire any more than necessary. So this is a map here of showing it. It will be on the north side, and then it will have a culvert going over to the south side, going to a rain garden where all of that runoff will go and finish infiltrating so all of those pollutants don't have to go into the river. And then for the parking lot, we will have an underground drainage system. It will be located right here in the parking lot, and it will help infiltrate and get rid of the suspended solids, especially with that first flush and within those first 15 minutes of rainfall where most of the pollutants are. And so this is what the underground storage looks like, where it will help infiltrate all of that. And then we have the rain garden, which will help with all of the runoff from the intersection. And it will all flow in through the inlets here, those 5 inlets to go to the rain garden. And we chose a rain garden because it's aesthetically pleasing and it helps infiltrate the water and get rid of all the pollutants. And it's educational, where They'll be able to see it from the visitor center, and there will be an outlet located there. So if the water does get too high, it will be able to not drown the plants. So this is a cost breakdown for the underground storage for the water, the rain garden, the vegetative soils, and the curb and gutter, which will have the inlets to get all to the rain garden. And now I'm going to pass it off to Ryan for the environmental.
Thanks, Holly. So I'm the environmental engineer for this project. So my scope includes water treatment for a nearby subdivision plus their visitor center, and then wastewater treatment just for the visitor center. So this red region right here is the Orchard subdivision. So I calculated a peak of 1 million gallons per day to be treated for the subdivision and our visitor center. And I have a proposed location in this blue area. So it is the area for the proposed water treatment plant is outside the scope. It's about 3.5 miles away. So first semester was mostly going over alternatives and finding out what I was going to do for my final design. So first had to decide on a water source, and it was between groundwater and surface water. So I ended up choosing groundwater for my water source. The city of Goshen currently has 2 water treatment plants that both use groundwater already. The surface water nearby that was proposed would be the Goshen Dam Pond, and it is currently impaired at the time. Since it's mostly farmland in the area, there's very high phosphorus levels and a lot of runoff, which then makes very low dissolved oxygen levels. There's a lot of sediment buildup in the Goshen Dam Pond, and it just wasn't ideal for surface water. So once I knew I was using groundwater, I looked at different types of water treatment. So there's precipitative softening, ion exchange, and pressure filtration. I ended up using pressure filtration as my main design for my plant, just because when I looked at groundwater and I saw the contaminants, there are very high levels of iron and magnesium, and pressure filtration can be the most effective with removing those contaminants. For the wastewater produced by the visitor center, it only has a peak flow of about 10,000 gallons per day. So a treatment plant wasn't viable for that small flow. I ended up concluding that the best system for the wastewater flow is just connecting to the existing sewer main. I was able to see the existing sewer connections that the city already has, and there are sewer mains running on both the roads surrounding the visitor center. So I was able to size the PVC pipe that'd be used, and it will be connected to the existing main. So here's the treatment train for the water treatment plant, and a little bit broken down better is a process diagram showing the whole process. So we'll have 4 wells that will then be pumped to an aeration tank, and from the aeration tank, the water will go to 2 pressure filters. There's 2 for redundancy purposes. They're 10-foot diameter with, they're 15 feet long. So one of the pressure filters can handle the peak flow for the entire plant. However, 2 were included for redundancy and for backwashing. Washing does need to occur, and so the backwashing water and the sludge that is removed during backwashing will then go to the lagoon seen here that will take place on site. And from that lagoon, the lagoon was sized to be dredged once a year for the city. So the Goshen Engineering Department can decide how often they want to dredge it, but it can hold a maximum for 1 year at the max rate. After that, there's disinfection and fluoride that will be added to the water that will head to a contact chamber. It has a detention time of about 145 minutes, and then to the storage tank, and then out for distribution. The storage tank was sized pretty conservatively. I sized it based off 3 to 4 days of the average flow of the plant. So here's just a diagram of what the pressure filter will look like. And I picked the media inside the filter, so anthracite and manganese green sand, and then gravel and a subfilter, and those were picked because those were the most effective media for removing the iron and magnesium that are the most important contaminants. Just a couple impacts. Our cost, because it is a city, tax prices will go up. Well, hopefully it will help the homes inside the Orchard subdivision and their home value increase though. Land acquisition, the land highlighted in blue will need to be purchased. And then adding fluoride to the water, it is in their standards. However, sometimes it can be a controversial topic for some people if they don't want a municipality adding fluoride to their water. So the entire cost breakdown for my environmental scope is, it was just under $10 million, it rounded to 10 million. And our total cost of our entire project is about $27.5 million. So finally, just wrapping it up, we presented the corridor design by Zack. With that, the intersection design. Mike presented the visitor center. I had the water treatment plant. Richie provided the geotechnical services and the foundations, and Holly provided water resources services. So with that, I'd like to invite the rest of the team up for any questions or comments.
I have two, both of them transportation related. Did you consider fixing that intersection where it's all set?
I did. So one of the main problems is north on State Route 15. There is a pretty confined space with all the businesses and housing along there. So it actually would have shifted a lot, and also kind of shifting that over. Most of them were on the west side, so that would have impacted a lot of the businesses, and there would have been a lot more right-of-way and property acquisition costs added to it. South side is basically the same thing as catch-22 on the whole project. Yep.
And then the other thing was the entrance to the facility.
Mhm.
Will that need to be signalized close enough to the intersection?
So yeah, the entrance will be signalized as well. We are looking at that. That was a little bit outside, so we didn't kind of get in it as it was 30% planned. So yes, that will be signalized as well.
All right, thank you.